So hello students, welcome back to the online lecture series for your subject RCC, which stands for Reinforced Cement Concrete. In today's lecture we will learn about what is RCC, what are the different ingredients by which RCC is formed, certain IS codes which are used for the construction and design of RCC. Okay, so let's start. So first of all, what is RCC? RCC is a heterogeneous which is formed by reinforced cement concrete. Okay, cement is a binding material. Okay, and concrete is formed by coarse aggregate and your mortar. Okay, here the term reinforcement stands for steel, so there is a thermal coefficient of expansion which is denoted by alpha. Alpha for steel is almost equal to alpha for concrete. Alpha for steel is 12 into 10 to the power minus 6 per degree centigrade, and alpha for concrete is 11.7 into 10 to the power minus 6 per degree centigrade. Here reinforced means to provide extra force by steel. As you know that concrete is much strong in compression, but it is weak in tension, or you can call it as flexure. So we provide steel as a reinforcement to provide the structure extra strength in flexure. Okay, so the basic ingredient, as the term defined RCC, is cement. It is binding material, and these are the four bogus compounds which are formed while the reaction takes place: C3F, C2S, C3A and C4AF. Weight per bag is 50 kg, it's important, and the density of cement is 1440 kg per meter cube. Okay, its volume for one bag of cement is 35 liter, so in 1 meter cube there is 100 liters, so you can convert it easily. And the specific gravity for cement is 3.15. okay, concrete is a mixture of cement, as we have already learned. Fine aggregate, it is also known as sand, whose size is less than 4.75 mm. Coarse aggregate, which is also known as gravel, okay, whose size is greater than 4.75 mm. Okay, the maximum size of coarse aggregate used in preparing RCC is 20 mm. So you have to remember this, that the maximum size which we will adopt while making RCC is 20 mm according to the IS code 456-2000. okay, I have already mentioned in my previous lecture that we will use a code for the RCC construction which is IS 456-2000. So while making RCC we have to go through these three parameters. First is assumptions, analysis and design. Okay, so this is a design subject, so we have to make certain assumption depending upon the method which we are adopting. Okay, in IS 456. So for IS 456 it is for plain and reinforced concrete. All the things which will be included in plain and reinforced concrete will be under IS 456. For cement grade, because we are using cement here, for cement 33 grade we will use IS 269. As you know that there are three grades of cement: 33, 43 and 53. okay, so you have for IS 269 is used for 33 grade of cement. Okay, and for reinforcement we are using HYSD bars, mostly HYSD bars. Here HYSD stands for high yield strength deformed bars. Okay, we will learn about types of bar in the next lectures. So we will use IS 1786 for HYSD bars. For load consideration, because there are many types of load coming on the section, we will consider IS 800 for design of steel structures, IS 1343 for pre-stressed concrete, and IS 1893 for design of earthquake. Okay, so the most important code is here IS 456. Okay, so there are certain common terms which we will go through in today's lecture. First is characteristic strength, which is denoted by FCK. Okay, so what is the characteristic strength for any concrete cube? So it is basically the compressive strength of concrete cube of size 150 into 150 into 150 mm. Okay, so like this, if it is a cube, so it will be having 150 mm dimensions in all the three sides. Okay, so when we cast a cube of 150 mm size for 28 days, such that 5% result are expected to fail, it means 95% result are to be passed. It means if you have made an M20 grade of concrete and you have casted it in a form of cube of dimension 150 into 150 into 150 mm, so after 28 days it should give minimum 95% strength of the total design strength. If it is giving, then your mix ratio is good and it can be accepted. But if this does not satisfy, it means the result are failed and you have to do the mix proportioning again. Okay, so below I have mentioned some grades of concrete and its characteristic strength. So first of all, there is an ordinary. So first of all, there is an ordinary concrete. The ordinary concrete have grades M10, M15 and M20. These types of grades are used for ordinary construction, and its characteristic strength at 28 days is 10, 15 and 20. All these values are in Newton per mm square or megapascal. Okay, and another one is standard concrete. Standard concrete ranges from M25 to M55, which is used for high strength construction, and its characteristic values are 25, 30, 40, 50 and 55. So from this table you understand that the M denotes for mix and the number whatever it is, M30, M20, this denotes the characteristic strength of that particular grade. Okay, so only by knowing the grade value you can find out its characteristic strength. And last one is high strength concrete, which ranges M60 and above, so it is used for mega structures. Okay, so there is some note here. The minimum number of cubes used for compressive strength of concrete according to IS 456 should be 3. Means if you are testing any grade, so you have to make minimum 3 cubes, then only that particular value will be satisfied. And the minimum grade used for concrete for RC structures is M20. So you will not use a grade below than M20 for RC structure. Means while you are putting steel in any concrete, it should be of minimum M20 grade. Okay, so it have certain terminologies which is there. So first one is target mean strength, which is denoted by F suffix m. Its formula is Fm is equal to FCK plus 1.65 delta Okay, here delta terms is used for standard deviation and its formula is given below. Okay, so there are certain values for grades of cement. So for M10 the standard deviation is 3.5 and 15 again 3.5. M20 and M25 is having a standard deviation of 4 and M30 and above is having a standard deviation of 5. Okay, so it is also mentioned in your IS codes, you can check it from there. Okay, so after this there is a distribution curve which is used for the analysis of characteristic strength. So this curve is between the frequency and characteristic strength. So as you can see from this curve, it is like a bell shaped. So it is also known as a bell shaped curve and it is known as distribution curve. Okay, so this gives you a brief idea that how we select the characteristic strength from different samples which we have taken. Okay, so for design mix it is prepared at site, and for nominal mix standard mix proportion according to IS 46. Okay, so till M30 the grades are nominal mix, and if we are making and concrete above M30 you have to do a design mix according to the site condition and IS code. Okay, after this flexure strength of concrete, it is also known as tensile, or means you can say it like the bending strength of concrete. It is denoted by FCR and its value is 0.7 under root FCK. Mean it is 0.7 times the under root of the characteristic strength of the concrete. Okay, so there is a small example I mentioned here. What will be the tensile strength of M25 grade? So by using the above formula you can easily calculate the flexure strength. So FCR is 0.7 under root FCK. Here FCK value is mentioned 25. Okay, because the grade is M25, so by putting this value in the formula we get 0.7 under root 25. It becomes 5 into 0.7 and the value comes out to be 3.5 Newton per mm square or 3.5 megapascal. So the correct answer is C. So this is a very short example which I mentioned here for your practice. Okay, another one is modulus of elasticity of concrete, which is denoted by E suffix C. EC, it is equal to 5000 under root FCK according to the revised IS code, and its previous value was 5700 under root FCK. So it might come in some competition exam, so I'm telling you that AC we take for now is 5000 under root FCK, but the old value was 5700 under root FCK. Okay, so here is also a small numerical. So what will be the modulus of elasticity of M25 grade? So here it is asking the value of EC for M25 grade. So again putting the grade value 25 in this formula, we get 5000 under root 25. So 5000 under root 5 becomes 25,000. So it is 25,000 megapascal, but the options here are given in gigapascal, so we'll convert it by multiplying by 10 raised to power 3. So it becomes 25 gigapascal. So the correct answer is A. Okay, so that's all for today. Thank you so much. Be safe.